On today's episode of Steel Creek Explorer, let's rock and roll. As you might have guessed, today's episode is all about geology, particularly park geology. So you may already have an idea that geology is the study of rocks and minerals, and you're exactly right. But it also includes earthquakes, seismology, volcanology, my favorite thing, paleontology, which is prehistoric life. Even the movements of water, whether it's above ground or underground, that's a subfield we call hydrogeology. Geology is so much more than just rocks. In fact, if we break that word apart, geology, it literally means the study of Earth. So it is a bit more of a comprehensive field than just rocks. But hey, what's our Earth made out of? Mostly rocks. And so that's a big part of it. And that's what we're going to introduce you to today. So many times we don't think of rocks as being anything more interesting than the stuff that we're putting down in our driveway or the stuff that we're walking on. But what if I told you that geology is actually the setting for every story that has ever taken part on planet Earth? Geology is this silent witness to the eons that is absolutely fascinating. So not all rocks are the same. There are over 6,000 different kinds of rocks on planet Earth. Most of those fit fairly neatly into one of three main categories. You have the igneous rocks. Those are rocks that start from a molten state, either lava or magma. So igneous, from that same word where we get ignite or ignition, it means made from fire. There are the metamorphic rocks, just like a caterpillar undergoes metamorphosis to become a butterfly. Metamorphic rocks are rocks that have changed form in some way. And then there are the sedimentary rocks made up of sediments. So sand might become sandstone, silt might become siltstone, clay might become claystone. And all rocks have a story to tell. Igneous rocks tell us about the birth of new rocks. Metamorphic rocks tell us about seismic upheavals in Earth's history. They tell us about mountain building events and the subduction of plates and the crashing together of continents. And sedimentary rocks, well, they tell us the story of ancient ecosystems. So just like some critter might be living on that sandy beach or in the bottom of that shallow ocean or lagoon, if they get trapped in that rock record, well, we call those fossils. So rocks can become different kinds of rocks throughout their natural cycles and histories. And so we call this the rock cycle. As I said, rocks that begin their life from a molten state, then they harden and cool into an igneous rock. And an igneous rock could stay an igneous rock for untold amounts of time. But if it becomes subjected to huge amounts of pressure and maybe a little bit of heat, then it might become a metamorphic rock, like this piece of gneiss. That's spelled G-N-E-I-S-S, but you can remember it that here at the Nature Center, we have a real nice piece of gneiss that you can look at. And either an igneous rock or a metamorphic rock may weather or erode into sediments that can become compacted and cemented together, and then you might end up with a sedimentary rock. In each of these cases, there are different kinds of rocks in each of these big categories, but this gives you just a brief overview of how the rock cycle occurs throughout Earth history. Here in the park, we have only sedimentary rocks. Now, in this region, in the Southern Appalachians, you can find hundreds of different kinds of rock types in dozens of different geological formations. And you can find metamorphic rocks and even igneous rocks. We have evidence of volcanism nearby in this region. But right here in the park, we only have sedimentary rocks, but we have 3 important rock units, and I'm going to introduce you to each of those in just a moment. As I mentioned, geology sets the stage for essentially every story that has ever played out on Earth. And the same with your story. If you've ever boated on a lake or a river, or hiked in the woods, or driven your car or your bicycle up a hill, the underlying geology is probably the reason that that water is where it is and that steep hill is where it is. And we'll see that when we explore the park in just a moment. So as I said, Steele Creek Park only has sedimentary rocks that make it up. But if you've ever visited Steele Creek Park, you know that there is a diversity of topography that's here on site. Well, there are 3 distinct rock units here in the park, and we're going to take you to all 3 of them. The oldest rock unit that you can see, remember that sedimentary rocks are usually laid down in horizontal layers with the oldest stuff on the bottom and the youngest stuff on the top. Now, the layers around here aren't always horizontal. We'll talk about why that is in just a moment. But it still is generally true that the stuff you find on the bottom is older than the stuff you find on the top. The oldest rock unit we're going to visit is called the Knox Formation, the Knox Dolomite. And so you can see it in this profile of the park. It's the largest unit that we have in the park and also in this region. We're also lucky to have exposures of a really narrow band of geologic formation in this region. It doesn't daylight in a lot of places, so we're fortunate to be able to see some of that here in the park. It's called the Lenore Limestone. It overlays the Knox Dolomite. And then the other formation that you're probably familiar with, even if you didn't know it by name, is called the Sevier Shale. The Sevier Formation forms virtually all of the miles of trails that we have in the park, and it's what gives way to the steep, what we call knobs here in the park and other places in and around Bristol. So the Sevier Shale Formation, each of these formations, they have different physical and chemical properties, and that changes the way that they lay on the landscape. We'll go see some of that right now. Well, here we are in that first and oldest of the rock units that we can see on the surface in Steele Creek Park. This right here is a lovely exposure of the Knox Formation dolomite. Now, the Knox Formation underlies most of the Tri-Cities area. Underneath parts of Bristol and Johnson City and Kingsport, you can find exposures of this rock right here. It's usually found in the low areas of the Tri-Cities area. And so this right here is the chemical cousin of limestone. A lot of people call this limestone, and you could be forgiven for that minor infraction. But this is actually the rock dolomite. Limestone is calcium carbonate, also called calcite. Dolomite here is very similar. It's calcium magnesium carbonate. So it's a little bit harder than limestone. It's got some subtle physical differences. Dolomite starts off as a true gray color and weathers to a whitish color. When we introduce you to the Lenore Formation in just a moment, that formation is true limestone, and it's a little bit different. The other thing you're going to notice about the Knox Formation here is, well, for one, you might notice the cave that's behind me. We're here at Quarry Cave in Steele Creek Park. Limestone and dolomite are the primary rocks in which caves are found in worldwide, but locally 100% of our caves are found in limestone and dolomite. One of the interesting things about limestone and dolomite is that they're actually soluble in water. It's one of their chemical properties. So it doesn't happen quickly. It doesn't happen right before your eyes. You can't stir limestone into your iced tea and dissolve it like sugar. But over time, cavities will form inside of limestone and dolomite, and as groundwater percolates through those rock units, then caves can be hollowed out by dissolution over time. The other thing you'll notice about this rock formation is that, like most sedimentary rocks, it is arranged in layers. We call those strata. But this formation, most sedimentary rocks are laid down originally horizontally. The layers or strata here are not horizontal. They are pitched up at about a 45-degree angle upward. So this is telling us about a great upheaval that occurred. What you're actually seeing here is the birth of the young Appalachian Mountains during their initial uplift at the end of the Permian period of the Paleozoic era, when the continents of Europe, Euramerica and Africa collided with one another. That thrust rock units up into the sky, and here you can see some of that geologic upheaval recorded on this rock face. Very cool. Well, we're hiking out of the Knox Dolomite here to take you to the next rock formation in the park, but I had to pop over and say hello to and introduce you to a friend of mine here in the park. And this right here is integrally linked to the geology in which it's found. This right here is a rare little fern around here called a purple-stemmed cliffbrake. And as that name suggests, cliffbrake, it grows right on the sides of cliffs, just like you can see it growing here. So its little roots have to be well drained. It can't be stuck in puddling water. But the other thing to consider for this little fern is that, remember I said that dolomite is different from limestone in that it's calcium magnesium carbonate? Well, any of you gardeners watching know that magnesium is a funny chemical when it comes to plants. In fact, it's toxic. It's poisonous to most plants. So a lot of the species that specialize in these dolomite cliffs, they have to have adaptations in place to deal with that high load of magnesium that's found where their roots are uptaking nutrients. And the purple stem cliffbrake is no exception. This is one of those ferns that can excel right here in the dolomite cliffs. Remember what I said earlier, that the geology is the setting for the stories taking place? That is very evident right here. This is one of my favorite rocks in all of the park. If you spend much time with me, you might hear me say that more than once, but I really love this rock. Because this right here, there's so much earth history that this rock has to teach us about. First off, so we're down on the old beach area right in front of Steele Creek Park Lake. And this is one of the only places in Bristol where you can get a good exposure of Lenore limestone. Remember, that's that narrow layer of blue-gray limestone that's found between the Knox Dolomite that we've already met and the severe shale that's going to be sitting on top of that. Well, this right here is actually both the Knox Dolomite and severe shale. What you're looking at is a geological phenomenon that's called an unconformity. It's basically a place where two rock units meet abruptly. So in this case, it almost looks like these two rocks have just been stitched or melted together. That's not what's happened. And in fact, many park patrons don't even think that this is a natural rock. They think that this is cement sitting on top of this rock. Nope. This right here is actually the Knox Dolomite, and this piece underneath it is the Lenore limestone. So remember that dolomite weathers to a whitish color and has this gray white on a weathered exposure. The limestone is more blue-gray. The limestone is just calcium carbonate. The dolomite here is calcium magnesium carbonate. So like that little friend we introduced you to up growing out of the dolomite that does okay up there. But yeah, so you might be thinking, now wait a minute, Jeremy, I thought you said that the Lenoir limestone is younger than the Knox dolomite. And the way that this particular rock looks, it looks like the dolomite is sitting on top of the Lenoir limestone. And you'd be right to point that out. But note, this unconformity is braided in and out of the Lenoir limestone. It does not unconform uniformly. I know it's a lot of the same words used over and over again. So in some places on this beach, the Lenoir limestone is on top. On some places, it's side to side. And right here, it just appears that the Knox dolomite is on top. But in reality, what's happening here is that those two rock units are interbraided together wherever you find them both. So really, really cool. Both the Knox dolomite and Lenoir limestone together in one place. Well, you don't have to be a geologist to recognize that the trail I just walked in on behind me and to my right is quite different from what's happening on my left. This right here is another one of those unconformities, just like we introduced you to between the Knox and the Knox and the Lenoir formation. This right here is the unconformity between those limestone and dolomite layers and the Sevier formation. We're on our way to the last big rock unit in the park, the Sevier shale. Remember that limestone and dolomite are soluble in water, and so they form the low areas in our region. Formations like the Sevier shale, they form these really steep knobs, or in some places nearby you may get almost mesa-like flat top mountains of sandstone, but they're not limestone, they're not dolomite. You have experienced this geology if you've ever taken a hike in the park. You may not know the rocks by their names, but your legs know them, and your huffing and puffing knows these rocks, and they know when you've changed into a different geological formation. The Sevier shale is where we go huffing and puffing in Steele Creek Park. Well, like I said way back at the beginning, it's no coincidence that the rivers and the lakes are where they are, and the medium-sized peaks and plateaus are where they are, and the high elevations are where they are. All of those are telling you a little bit about the underlying geology. That's the great thing about this science. Knowing a few of the basics about geology almost gives you X-ray vision. You can look at topo maps or hike in a new area and be able to make some reasonable, educated guesses about what's happening without even seeing the rocks. But here we are in the final rock unit, the youngest rock unit in Steele Creek Park, and this right here is the Sevier Shale Formation. So shale is a fairly shallow marine mudstone. So this right here is sediments that were deposited at the bottom of an ancient ocean. They're not carbonate, so they don't dissolve in water. And so that means that they stand in high relief on our landscape. They form these knobs that we refer to them in and around Steele Creek Park. Most of our trails go in and amongst these knobs. And I oftentimes credit the Sevier Formation for the reason that we have Steele Creek Park here at all. Because frankly, this geology in the early days of settlement was just too steep, too austere to develop. You could log it for timber, you could pasture some livestock on it, but you couldn't really put roads on it, you couldn't put buildings and houses on it. So if it weren't for the Sevier Shale Formation right here, we would not be having this conversation in Steele Creek Park today. Well, like we've learned, every rock in the world has a story to tell. Those three big categories we started with. Igneous rocks tell us the story of the birth of new rocks. Metamorphic rocks, They tell us the story of mountain building events and tectonic movements of the plates on the earth. They tell us the travels of rocks. And my favorite, the sedimentary rocks, they tell us about ancient ecosystems on the earth. Like you can see on this interbraiding pieces of limestone and shale, it gives you a detailed account of a sea level rise and fall over time. But even within those rock units of specific formations, every rock has sub-stories. So the three rock formations that we introduced you to today, the Knox Formation, that's filled with that primarily dolomite, the chemical cousin of limestone. We find curious little inclusions in that Knox dolomite sometimes. People bring these into the Nature Center and they're just convinced that they have found fossilized dinosaur eggs. And I can see why they would think that. It sure seems like they've got an egg-like anatomy to them. But this is actually something that's found especially common in the Knox Formation that's chemically different from the surrounding dolomite. This is a mineral called chert that gets deposited inside voids that are left behind in that limestone and dolomite. And this stuff you may be familiar with when it breaks. This is a weathered exposure, but when you see the fresh exposure, chert has this gorgeous glassy-like appearance. It can either be gray or when it's dark like this, we call that flint. This has been vitally important in the tool-making industry of humans right here in Steele Creek Park for thousands of years. Chert and flint are the primary component of stone tools from the first Americans. So we can find pieces of human stories in these rocks. As we move up in geologic time, you can find prehistoric adventures of life in the Lenore limestone. Some places we can find a handful of fossils, like this little marine snail that is looking at you in full face view if the soft parts were preserved. This is the top part of that sea snail shell, and this is the cavity where the little critter would have been living and looking at you. We find that in the Lenore limestone. And then as we hike up into the knobs of the park and we move into the Sevier Shale, we can find all sorts of organism stories, whether it be these fossilized graptolites, these little planktonic distant cousins of you and me. These are an extinct group of critters that are part of a group called the hemichordates. We find their little fossilized exoskeletons in the Sevier Shale. But we also find interesting mineral formations. Sometimes we can find crystals in the rock units here, whether it be calcite, or sometimes we find the little hexagonal prisms of quartz crystals. You name it, you can find it. Because remember, that's what geology is. It's the study of the whole earth, and it's the setting for all the stories that have ever taken place, whether they are human stories or continental stories or earth history stories or the stories of plants and animals and other organisms. Geology has its toes in all of that. So whether you are coming to Steele Creek Park to explore the geology or hike on the Sevier Shale or boat over top of the Knox Dolomite, be sure to come visit us, because here's where you can be the explorer.